Welcome everybody to the webinar for today to assist you guys, and that is part of the build up to the 2022 InterVarsity competition. My name is Adele Croft and I am part of Food Focus, and it gives me a pleasure to assist the university to set up these webinars to assist you guys to make sure that you are busy planning the best beers for this year's competition. This morning, Anton Erasmus, who is the trade brewer at SAB, was supposed to be part of the event. Unfortunately, he couldn't make it. So he will definitely be with us on Friday, and then you will definitely hear from Anton and their involvement. Now, I would like to present you to your speaker today, Jacques Janse van Rensburg. He is from Lallemand. He's going to speak to you about fermentation variables. But before I hand over to Jacques to start his presentation, I would just like to tell you a little bit more about Jacques. His path in the craft beer industry started with him becoming a home brewer whilst completing his MSc at Stellenbosch University in wine biotechnology. He evaluated the effect of a consortium of non-Saccharomyces in small-scale winemaking and downstream effects on malolactic fermentation with Unococcus uni. All those names makes me think, Jacques, that there's definitely a lot of knowledge with you, because I'm even trying to pronounce those interesting words. His academic career led him to pursue fermentation as his primary interest, and he started working for Anchor Yeast at Lallemand Brewing in 2019. His knack for yeast fermentation in beverages has been always with him and has inspired his love for craft beer. The variety of beer is extraordinary to him. For him, it's not just as simple as raising a glass with friends and family. He evaluates every moment of sensation from pouring to the last sip. So I can definitely see, Jacques, that you have got a love for beer, and therefore we are really looking forward to having you present to us today.
Thank you so much for the introduction. Today I'll be talking about different fermentation variables. Not all of them. We'll be mainly focusing on ones that are revolving around yeast specifically. So just as a quick overview, I'll be talking about yeast, temperature with fermentation, and a little bit about wort composition. Specifically with yeast, we'll be talking about strain selection and the pitching of said strains. Another aspect that you can certainly look into is the quality of yeast, but seeing as that I work for a dry yeast company, and 9 times out of 10, especially at small scale, you'll be working with dried yeast. That aspect is kind of taken care of for you already. The yeasts are already at their desired viabilities and cell counts that you need, so we won't be focusing on that as much. As for wort composition, I'll be wanting to focus on free assimilable nitrogen, otherwise termed as FAN. This has a huge impact on fermentation, especially when you're dealing with adjunct brews or even just pure sugar wash fermentations. Obviously, then the different types of sugar that you have and sugar levels also play an influence, as well as the pH. But seeing as that beer wort tends to be buffered at standard levels of sugar and pH, I won't be delving too much into that. Dissolved oxygen is also a component, but it's more for the initial stages of fermentation, everything prior to 12 to 24 hours, and tends to lose its effect later on in fermentation because of fast consumption in the initial stages. And then lastly, something that can also be looked at is purely just your vessel design and geometry of your tanks. It does have an effect on how you process your beer and how to crop yeast, but doesn't really have as much of an effect on fermentation as the other topics that I would like to cover. So all of these factors that I've mentioned here basically relate to the quality of your beer that you're going to generate, your fermentation curve that you can obtain, as well as all the different flavors that are involved in beer. So let's start with selecting a yeast. This is normally the first step after you've designed your beer recipe that you want to do. So you actually start at the bottom rather than at the top. If you've decided you want to go for an IPA yeast, then you're obviously going to be going for a yeast that is selected for beer fermentation and doesn't occur in other industry. And even if it is fermentation specific, you know, beer yeast utilize sugars differently to what other yeasts do, such as wine or distilling yeasts. So naturally from the top, obviously, you're hopefully going to be using a yeast to perform your beer fermentation. Is it baking or fermentation related yeast or something for enzyme excretion instead? As we trickle down the tree, we've obviously selected beer, and then after that we have a whole plethora of strains. These are just 3 examples that I've mentioned here. There's way too many to mention, so I'll just leave it at there for now. And ultimately what you're going to be looking for is a yeast that can not only survive a fermentation, but also complete it to attenuate to the proper levels, get consistent and reproducible results in your fermentations, and is able to utilize the sugar specific to a beer matrix. For instance, rum or wine fermentations, rum has a high sucrose content with a bit of glucose and fructose, whereas wine has mainly just glucose and fructose in it. Beer yeasts don't do very well with fructose, so they might be able to eat the glucose very well in the fermentation, but not necessarily consume the fructose as a sugar. Conversely, is the same. Beer has a lot of maltose, maltotriose, and glucose. There's very, very little fructose, if any, in those fermentations. And wine yeasts are going to struggle to ferment maltose and maltotriose, although they will attack the glucose. So it is very important to bear in mind, where does your yeast come from, and is it applicable for the matrix that you're using it in? Then obviously, now you've selected, okay, you want to make an IPA. There's then a whole bunch of different strains within the IPA region that have different fermentation rates and characteristics, you know, different flocculation levels. Are they applicable for, you know, repitching easily? Do they retain their viability, and do they store well? So these are all characteristics that you need to bear in mind. Just for simplicity and, you know, out of convenience for our range here at Lallemand Brewing, the widest selection for strains that we have is currently our IPA range, which is something that I'm going to take you through now. So these are the typical standard parameters that you would look at, you know, when busy scrutinizing between your different IPAs. This comes from our best practices document that our marketing team has put together for us. So I'll be borrowing the information from there. As you can see, we have 5 different strains on offer at the moment, and all with different attributes. So we have New England that has different attenuation level to, for instance, Windsor and Verdant, but then these 2 are more similar. Nottingham would be the highest attenuation strain that we have. Then there's other aspects to take into account, such as their flocculation levels, their different alcohol tolerances, and then the amounts of biotransformation that they would do. If you're looking at lager strains, for instance, biotransformation is not something you're interested in as much because it's supposed to be a neutral style. So it is very dictated by the recipe that you have. So for the sake of example, where the most diversity, at least in my opinion, can occur, I want to talk you through these IPA strains. So dependent on where you want your recipe to end, for instance, do you want a lower attenuated beer? So then you might want to think about using the Windsor in an English IPA, or the Verdant in a New England IPA, or New England. But New England does just as well in West Coast style IPAs. It's often used as an alternative for Bry 97, and Nottingham is just a go-to yeast. It's very, very neutral, which we can see in these flavor wheels over here. So this is another aspect that you need to maintain when you are busy selecting your strains. Is the overall flavor that it's going to be contributing conducive to the beer that you want? Windsor, for instance, is very well, very good to be used with the English IPA. It can attribute to a bit of the floral notes, but it also has a bit more red apple and tropical fruit than, say, what Nottingham would have. Verdant has the I would say, best overall balance between these two pies, slices of the pie, whereas New England is a little bit more favoring towards the tropical fruit. The way I have at least experienced these two strains in IPAs between the New England and the Verdant specifically is that one kind of is more akin to a breakfast punch pulp juice, and the other one reflects more to the skins of the different fruits. That's just my personal experience with the strains. It will be different to everyone and how they describe it, but between the standard parameters above, which is designed by recipe, and the flavor that you're going to get out of your yeast is where your decision making needs to come into play. So West Coasts would definitely be Bry 97 or Nottingham, East Coast / West Coast New England, East Coast and Naples New England and Verdant, and British IPAs between Nottingham and Windsor. So there's a bit of crossover, but you need to know how you're going to manipulate your yeast to get to those end results. So just to compare the fermentation profiles between the different IPA strains to illustrate that you know, the different yeasts will perform differently. Take for instance what we have with New England and Bry 97. So this is assuming a standard inoculation of 100 grams per 100 liter or 1 gram per liter in the standard 12-plater wort fermented at 20 degrees Celsius. You see that strains such as New England and Bry 97 and even Nottingham can have a bit of a longer lag phase, whereas the Windsor and the Verdant tend to start getting into action straight away. And that's just how the yeast responds in the initial lag phases of the fermentation. They tend to, these strains, for instance, will have a very aggressive start, but then not attenuate as far. So Windsor, for instance, attenuates the least. Then we have followed closely by Verdant, then New England, Bry, and Nottingham ending up quite closely with one another. So this is just showing the fermentation kinetics of how each strain can differ. And it's not to say that New England necessarily ferments slower than what Verdant does over the bigger picture, because they get to roughly the same amount of sugar given a certain space amount of time. The attenuation is rather what you should focus on, at least in the way I see it. Flocculation of between the different strains also come into play, given the specific assay of the HSBC method that we use. Apparently Nottingham has the highest flocculation, followed by Verdant and then Bry, with Windsor being the least flocculent. What this translates to is how easily it is to crop your yeast. But if you have different ways to propagate and crop your yeast into different fermentations, it can just make your life easier or not. It's not necessarily to say that one strain is easier to repitch than another. If you do manage to get all your yeast down by the uses of process aids or standard methods such as cooling, you should be able to pitch your yeast accordingly if you have the correct micro lab to be able to scan for them. So for those of you who don't know, just to remind you that flocculation, it's when the cells form clumps over time, particularly towards the end of the fermentation. So this is 3 micrographs of a non-flocculent versus a slightly flocculent and fully flocculent strain. But if you get a flocculent strain during fermentation, it will be like this, and through fermentation, as it progresses through time, they start forming these clumps which sediment to the bottom, which you can see with the graph over here. So the y-axis is the yeast in suspension versus the percentage attenuation, which is kind of just a measure of how far in fermentation it is in terms of sugar utilization. And we see here with the flocculent strain, once it reaches towards the end of fermentation, the cells very quickly drop out of suspension, whereas the other one lags a bit behind. So these ones will tend to need a bit of help to flock them out. But all of this can be made easy for you. We have a strain selector in our new Lalbrew app, which is available on both Android and iOS on the Play Store and App Store. So if you're interested in what strains you can use, at least from our portfolio, you can download the app and go through the strain selector, and you can put in all these keys over here. So you can say you want a medium attenuation or you want a high attenuation. Do you want biotransformation, what is your starting sugars going to be. You can put in those kind of standard parameters, and it will suggest to you which strain is best suited, at least for that fermentation. But you can always reach out to either myself or any of my colleagues to get our viewpoint and where you would like to go with your beer. And that brings us on to yeast pitching. So you've now selected your yeast that you want to use. Now the question is, how much of it do you want to use in your fermentation? And this all depends on your wort gravity, your fermentation temperature you're going to be employing, how much aeration or oxygenation occurred prior to pitching, the strain condition, is it dry, is it wet, and also what type of desired flavor profile do you want. Conveniently, we also have a pitch rate calculator for every strain. So you just key in the parameters of gravity, volume, strain, and temperature, and it will give you an estimate of where you should be. But again, consult either myself or any of my colleagues to get a better feel of where you need to head into a direction. The figure on the right is basically just a very, very old source to show the trend between pitch rates and fermentation time. And what we see as a general trend is that the more yeast you have, in general, the faster fermentation will be, especially in the initial stages, as well as level of attenuation will differ. So you should tend to get a higher attenuation in your fermentation with more yeast than what you would with less. Obviously, this assumes some constant parameters such as temperature and nitrogen composition in your wort, but this is just the general picture. So if we look at Nottingham in general, we have a figure here that I've stolen from one of my colleagues who gave a presentation on this a long time ago, but I feel like it captures the picture quite nicely. So here we have Nottingham fermentations performed at either 0.5 gram per liter or 1 gram per liter at different temperatures, either 20, 15, or 10 degrees Celsius. And again, we see that 1 gram per liter fermentation at 20 degrees is faster than when it's at 0.5 gram. But the attenuation difference is not so high. We see more difference of attenuation when we get to colder temperatures. So in the moderate temperature, we even see actually a faster fermentation time for 0.5 gram per liter, and there could be many reasons for this. It's the yeast that's busy growing, or it can be the composition of the wort. So the general trend is still true because it starts lagging later on, possibly due to the growth of the yeast that have consumed extra nitrogen to not have focus towards fermentation towards the later stages. And it's certainly true here in the 10-degree fermentation, where it's going to be a lot colder for the yeast to ferment. So it's going to struggle to grow to achieve the proper population level to even carry out fermentation, which is why we have this extended curve over here and not even achieving final attenuation. So again, in general, we do see a faster fermentation for a higher pitch rate, and we see a slower fermentation with a lower degree of attenuation with lower pitch rates. And this assumes that temperatures are similar for a given pitch rate, as well as the nutrition levels in the wort. So what I alluded to earlier is that pitch rate basically will be affecting excuse me, the rate at which your yeast will grow in the initial stages of fermentation. They have a way of sensing and measuring their population within a fermentation, and their goal is to achieve that optimal population in a way so that they can facilitate fermentation. So if you have a lower pitch rate, it tends to lead to more yeast growth, which obviously affects the flavor, because as yeast grows, you get the production of different byproducts due to the metabolism of yeast. You'll also get the consumption of nutrients in the wort, which is no longer directed to the maintenance of fermentation, but rather into cellular growth, which depletes the nutrition in a way. Whereas if you go for a higher pitch rate, there should be less yeast growth, which leads to a more neutral flavor in general, and more nutrients available for fermentation. Excuse the spelling error on fermentation here. Here's a standard curve that I also stole from my colleague, of depicting pitch rates on the x-axis versus the amount of yeast growth that was experienced during fermentation, we see that as the pitch rate increases over here, there's a bit more yeast growth to an extent. Then when we reach tipping point, there's no yeast growth that's occurring anymore. That's depicted by the total yeast we see in suspension. So after a certain point, the yeast doesn't grow anymore and won't activate those pathways to generate extra flavors and consume extra nutrition. This now brings us to fermentation temperature. So we've already seen the effect that temperature has on a fermentation. It's mainly dictated by recipe and style. So a lager, of course, is going to be fermented at cooler temperatures because the style dictates it at so between 12 to 14 degrees. With ales, it's anywhere between 18 and 22 degrees. Some people even do it at 16. It is dependent on temperature. It's to be used in conjunction with pitch rate, and it affects the flavor of your fermentation. So if you have a fermentation temperature that encourages yeast growth, it is going to get more fruity. If there is no yeast growth, it can be more neutral. But then you have the other factor, which is your strain. So if you use a Belgian strain, for instance, like the Bell or the Farmhouse, and you have a warmer temperature of 22 degrees Celsius, you're not necessarily going to get fruit, you're going to get more spice. So there is a change with yeast strain too. So going back to the graphs that we've seen earlier, I just decided to throw in an extra figure that is showing the effect of an adjunct, because I'm going to be talking about wort nutrition later. What I want to bring your attention to is the difference in temperature. These two graphs are obviously the higher temperature with the moderate temperature here and the lower temperature. And we definitely see slower fermentation rate and higher attenuation levels across the variables. We see a similar thing occurring when adjunct is used. However, interestingly enough, when you get to a lower temperature here for this specific wort with 40% adjunct, it actually failed to attenuate. And this has got to do with the content of nitrogen in your wort. So adjuncts, depending on the adjunct you're using, does affect your wort nutrition. If it's just sugar you're adding, you're actually creating an imbalance between your nitrogen and your sugar levels in your wort, and it needs to be accounted for. So getting onto flavor, what does pitching and temperature do for flavor? We see it has an effect on the esters and higher alcohols that are produced in your beers. In general, as your yeast grows, it should produce more esters, which correlates to a lower pitch rate or a higher temperature, which we see here. So with ethyl acetate in a regular wort, we see an increase in the concentration of ethyl acetate going from 1 gram per liter to 0.5 gram per liter. So the yeast grew more, which was leading to the fact that it was able to produce more esters. We see it with the 15 degree, but to a less of an extent with the 10 degree fermentations. In general, with 10 colder fermentations, metabolism is a lot slower, so the amount of change that we expect to see should be a lot less. Conversely, we see with a decrease in temperature, given a specific pitch rate, we see that the amount of esters actually decreases. So as you decrease to 10 degrees, you'll get less of an expression of ethyl acetate, for instance, given a constant pitch rate of 0.5 gram per liter. It doesn't explain why we see a little bit of an increase over here. And that could be just due to that more of the ester is locked into the matrix while it's busy fermenting, because it is a lot cooler. So we mustn't forget the effect of blow off at warmer temperatures where esters are able to become more volatile. If we take a look at an adjunct wort, for example, the matrix is completely different to regular worts or slightly higher concentration sugar worts. So what we see here is the effect of the nutrition of the wort, how it affects the aromas that get produced. And we see it the same over here for isoamyl acetate. So we see the increasing ester concentrations given decrease in pitch rate, and the decrease of ester concentrations given a decrease in temperature. Higher alcohols, it has the same trend. Excuse me. So again, we're seeing a general increase of higher alcohols being produced with a lower pitch rate, and a decrease in higher alcohols produced with a lower temperature. So this brings me on to word fan, especially because of those anomalies that we saw with the adjunct beers. So as mentioned, fan is the free assimilable nitrogen in the wort, which is basically describing the amino acid content, the ammonia content, or diammonium phosphate, which we use as an additional thing in beer brewing. It's consumed during fermentation for the production of enzymes for glycolysis in fermentation, and also for the manufacturing of cell components in yeast growth. How it affects flavor is that if your yeast is growing, it doesn't have enough nitrogen available to facilitate fermentation, which can lead to the yeast thinking that there's not enough nitrogen to go around, and it can start kicking off hydrogen sulfide. Now, hydrogen sulfide is another topic completely on its own. It's able to, it produces hydrogen sulfide actually in all fermentations, but to the extent of how bad your H2S manifests is definitely dictated by the nutrition in your wort. But as another way that fan can affect your fermentations, aromatically speaking, is by the use of branch chain amino acids. There's a specific pathway that is known as the Ehrlich pathway, and it basically talks about how an amino acid with a long complicated chain is converted into either a aldehyde or an alcohol via oxidation or reduction with a key intermediate of an aldehyde. So the yeast eats these complex amino acids, scavenge the amino group so that that amino group can be used in the production of enzymes for fermentation. And as a result of that, the backbone of this keto acid is then used to generate a aroma active higher alcohol, or a ester, which we then perceive in beer and in wine, obviously. So people who use diammonium phosphate don't benefit from this at all, which is why I like to tell people to try and use an organic nutrient where you can, where you will have these amino acids in abundance, and also try and steer away from adjuncts where you can, because you will have more of this. Technically, you should have more of this in your well-modified worts with proper malted grain or malted barley. Corn can give some interesting things, but if you're just using plain sugar to up your SGs, you're losing out on this heavily. So what does fan do? It definitely makes a better fermentation up until a limit. There's a long, complicated story as to why that is. And a short way to describe it is that yeast is very, very greedy. If there's a lot of nitrogen in abundance, it basically has a party and says, we need to up our yeast population, and it does so. But by doing that, it decreases the nitrogen available in the wort. And then it sits in the same problem as what it had as if it would have had right at the beginning, with too little nitrogen for that population. And that's when you get sluggish fermentations. They're not finishing to the proper attenuation, and they are throwing off flavors like H2S, for example. So over many, many trials, literature has basically described that anywhere between 150 to 250 milligrams per liter, or parts per million of fan, is what is needed for successful fermentation for anywhere between 12 to 28 Plato. We see this in wine, we see this in beer, we see this in distilling. So when you're using a high adjunct wort, it is very important to make sure you have enough nutrition for your yeast to ferment. And this is just an illustration of two different dosage rates. So we have, along with pitch rate, obviously, we have 100 grams per 100 liter of yeast life O, which is an organic nutrient that's being used here specifically in just plain sugar and water. This is what is known as a sugar wash, or something that is used for hard seltzers. So there's no other interrupting factors from wort over here. this is to just illustrate the differences of concentration that fan can have. Just important to note that this dosage here of yeast life O does not equal the parts per million of fan, because this is a complex nutrient. It has a lot of fatty acids, it's got vitamins, it's got a whole bunch of extra factors, not just the amino acids that are at play. But what we do see is you've got to compare across the graphs here. We see that the orange line over here is definitely reduced when we have a lot more nitrogen being added across both rates. Attenuation is actually even better for the 50 grams per 100 liter. It reaches the same attenuation level. So here it's showing that, you know, you could maybe use less yeast if you wanted to, so long as you provide the correct nutrition to support its growth. So once it's reached its proper population level for fermentation, it can do the job fine, and you might even get the benefit of extra aroma because it grew during that process. So these are all the little things that you need to think about. Are you going to be feeding your yeast? What pitch rate are you going to be using, and what temperature? So this was at 20 degrees Celsius. You'll definitely see the changes from different temperatures too. But just to make it not as busy, I decided just to leave it here at stat for 20 degrees Celsius. And if you're wondering what nutrition products there are out there, there's 3 main types for beer. There's a complex nutrient, which is yeast life extra, that's been going around recently. It's got a lot of zinc in it, some free amino nitrogen in the form of amino acids, as well as diammonium phosphate. It's got some fatty acids too. It's known as the one to tick all the boxes. And an example of it looks like this on the right hand side. I didn't happen to have a picture of the product packaging, but it basically looks like yeast life O, just with yeast life extra on the right. Then we have organic nutrients, which is yeast life O. Has a lot of free amino nitrogen in there, mainly in the form, or actually exclusively in the form of amino acids. It's completely organic. There's no diammonium phosphate or urea. And obviously it's got some fatty acids. It's made from growing yeast in a certain way to be high in these nutrition, and then killing them off, or what's otherwise known as autosolizing them. It's mainly used in sugar fermentations and hard seltzers, but there's no reason why it can't be used in an incredibly skewed adjunct brew. Then we have something else which I didn't really talk about. It's a specific nutrient like servomyces. This only targets zinc. It doesn't have any nitrogen contribution to it. And zinc is another story when it comes to fermentation. It's got mainly to do with repitching and the vitality of the yeast. Zinc is a source in fermentation that gets diluted over time. So you've got to have a really good wort, and if you don't have that good of a wort, then you need to supplement in some zinc. And that's it. I'd like to thank everybody for listening. If you guys have any questions, remember we brew with you. You're more than welcome to email me or download the app and post a question there. And yeah, I'm open to polls.
Wow, Jacques, that was an extremely technical but extremely informative presentation. And I can see from the questions that I will post to you now, as well as the comments that were made, that the yeast is such an important, probably the most important choice that they will be making. So I'm going to start with the first question, and it is adding fruits like strawberries and bananas during the mashing stage. What will the effects be on fermentation and taste, and maybe the aroma as well?
So fruits in the mash is something I'm always worried about, especially when you're dealing with pectinous fruit, because you can be making a jam without knowing it, or you get some haze in your beer. I would say add juice, fruit juices to mid stages of fermentation or late stages of fermentation, purely because of the pectin issue. Also, if you are mashing with fruit, you can get like a stewed or a cooked fruit type of characteristic. The yeast will be able to use the sugars, no problem. And there obviously are essential oils on fruits that are very akin to hops that the yeast can work on. It can still do some biotransformation. So yeah, throwing in orange peels, obviously if they're clean and not dirty, throwing in a few orange peels during fermentation for verdant, for example, to work on should be fine. That really shouldn't be a problem.
Okay, then how is pitch rate calculated? Which methods and technologies are used?
Okay, so when you're working with dry yeast, for example, the manufacturer will often have a certificate called a certificate of analysis that will describe how many cells there are per gram. And you can go and work it out to the gram, how many grams you need. But what we do as a manufacturer is we have a general range of where you can work from. So for instance, Nottingham is between 0.5 gram to 1 gram per liter. And those values should put you in the ballpark figure to get you to the population that you need to initiate fermentation properly. Otherwise, you can use the pitch rate calculator to actually figure out how much exact of weight you need of that yeast specific strain, given sugar level and volume and temperature, which we have obviously got a database of where they've done these over and over and over, and it's basically just a model that's fetching a value based on those parameters. Otherwise, what people will be doing is cell counts. So if it's a liquid strain, they'll be putting it under the microscope and counting how many cells there are in that suspension, and then based on that, they just do a dilution assay and it goes into the beer.
Okay. Another question that I've got is, would you recommend in mixing yeast strains?
Yeah, it depends what you want to do. There's always room for co-inoculation. This is what my MSc specialized on, just in wine. Beer, you just need to remember is that there's a lot less background ongoings to mask anything that goes wrong. There's no phenols from red wine. There's no aroma from the grapes that much. So sure, you're getting it from the hops, but it is in general a much cleaner matrix. So when you're pairing yeast, do it in such a fashion that they're not competing against each other in a way. For instance, with the Philly Sour, it's our sour strain. It does the souring of the wort in the initial stages, but it is a little bit longer to ferment, which you can take advantage of by throwing in something like Verdant or Bry 97 that has a high biotransformation on it, whereas Philly Sour doesn't necessarily have that. So use that to your advantage. Otherwise, you can go the weird route and throw Bry 97 to work on the hops along with Belle Saison to give the Saison type of characteristics, because the Saison, the Belle Saison has that SDA gene to make your beer attenuate lower over time. So you've got to use the strains where they complement one another. Otherwise, if you're going to just throw in Nottingham, it's neutral. It's going to ferment very well. And then you're going to throw Bry 97, which is also good fermented, but then it has a high biotransformation. There's no real benefit in that.
Yeah. With that answer that you gave me, I think Hendrik is taking it up nicely, and he's asking, are there any material and literature about your topic today? I know you've mentioned the app, but he wants to know, if he can get more information on this and where he will be able to get it. And he was thanking you and saying that your presentation has been extremely useful, and he sees that there's a need for studying more on this. So in terms of the material and literature, where is it on the app, or where do you suggest they can go for more information?
Well, to cast a wide net, you can surely ask a question on the app. It will probably land on the desk of my colleague Eric, who's our global technical advisor, and between all of us at Lallemand, we'll be able to find some literature for you. I'm sure there's one lying on the desk. I personally haven't seen any literature related to beer on co-fermentations of yeast, but of course there's been a plethora of it in wine, but that's just because of the nature of wine. It's already a non-sterile type of fermentation, but we're more than happy to help. So I can have a chat with my colleagues and see what we can do. And then you can just reach out to me on email.
Wonderful, Hendrik. There is an open invitation. So I will definitely make use of that if I was you. Then another question is, does Lallemand supply commercial nutrient products?
Yes, so that last slide was basically covering that. So it's the Yeast Life Extra, which is in country. We haven't had a huge demand for Yeast Life O for hard seltzers. Not a lot of people have been doing it, and there are other alternatives which I can help you out with. And then Saccharomyces. Those are the three brewing specific ones.
Okay, so do they make contact with you if they would like to know? Okay, wonderful.
They will ultimately be working through my distributor, Cactus Craft, but yes, there is stuff in country that we can definitely get there.
Okay, Hendrik is very glad to hear that, so that's all good. If there's any other questions, please would you put them into the question, or otherwise, like I mentioned, you can raise your hand and then you know, we can ask you the question directly. Okay, then there's someone that said, I stand under correction, but it seemed that the speaker from yesterday is cautioned against using nutrients, as if it gets overused, you can start poisoning your yeast.
Yes.
And that the commercial yeast, okay, shouldn't typically need the extra nutrients. Do you have any comments on that?
So again, it's something maybe I didn't hammer on enough, is if you use too much nutrient, it can definitely be a problem. I think I mentioned it in my talk where I was describing that the yeast senses that there's enough nitrogen around, and it has a bit of a party and makes too much yeast population. And then it sits in the same problem as if it had too little to begin with, and it gives you all flavors and the like. But toxicity, I think, is what he's referring to, or she is referring to, is zinc. So zinc is something that is added in very, very little doses. For instance, the Yeast Life Extra and Saccharomyces, it's such low dosages of like 1 gram per 100 liter for zinc Saccharomyces and 4 grams per 100 liter for Yeast Life Extra. So those commercial nutrients have been worked out to supply just enough, assuming that you are using a normal standard modified wort. There is a lot of information out there that also shows that malt does have variability. You're not going to get the same FAN and zinc and vitamin levels every single time. And by using that as an insurance policy, it costs like something like, for a commercial brewer, it's 4 cents per liter to have that assurance. You know, it can mitigate a lot of problems. And if you just use it within its bounds and don't get too overexcited with it, you can get amazing fermentations. I've had a lot of trials recently in industry now where people are definitely seeing the benefit of it because they are underpitching. 9 times out of 10, people want to underpitch because they want to save on money, and that's when nutrition comes into play.
Okay, awesome. Thank you very much, Jacques, for answering all the questions and making yourself available, you know, for the students to reach out to you further. We really appreciate that. Olga, I'm going to hand over to you now so that you can just say a little bit more about the other 2 webinars coming up this week. And just saying thank you to Jacques.
Thanks, Adele. Yes, thank you, Jacques. That was a very informative presentation, and I could hear from the questions that everybody's really interested and excited about this topic, which is a good thing, because if you are not attending this competition for the first time, you would know that Lallemand is a new sponsor to the InterVarsity this year, and you are all in luck because they are very generous and sponsored 5 yeast strains for each team. So you should be receiving 5 or 6 11-gram sachets of lager yeast, Philly sour. What's the other one now? I've forgotten. Anyway, and then yes, Voss, sorry, so that you can up the temperature a little bit and play around with that. And then also, I'm glad that you spent some time on talking about the ale or the IPA strains, Jacques, because we used a random number generator, and we're going to send each of the teams a different strain just to mix things up a little bit. So do go back to the recording on the microsite if you want to revisit the information that Jacques shared, and also try out the app, of course, if you want to get the most out of your yeast. If you by any chance get a strain that you decide you don't like and you want something different, then you can use your R1,000 voucher that BASA is going to sponsor for each team to buy maybe some of the yeast nutrients or a different strain if you choose. Then Lallemand and Siebel Institute of Technology also will sponsor an all-flavor sensory training roadshow for us this year. So we don't usually try to brew beer so that it has an all flavor just so that you can know what it tastes or smell like, but it is very important to actually practice so that you can know what the problem is before you can make any adjustments in your fermentation. So Jacques will be traveling the country around the first 2 weeks in June. We will share more information with that with you on that soon. So he will do this all flavor sensory training for us in 5 locations. We'll start out in Pretoria, and then there will also be, he will also visit KZN, Bloemfontein, Port Elizabeth, I don't know quite how to pronounce the new name yet, and then also Cape Town. So if you want to volunteer to assist with this roadshow, you're welcome to contact me so we can get you involved. And yeah, that should give you a very good idea of what the all flavors smell and taste like, rather than just having to imagine them. Then I think that's all from me for now. So please remember to attend the Thursday webinar. We have Miraldi Kotze from the CUT team. She's also the lead judge for the label design for the competition. So she will share some information with you on the do's and don'ts for label design. And we are going to make a couple of changes to how the label design is judged and what you're supposed to do. So please be sure to attend the Thursday session. Thanks, Adele.
Wonderful. Thank you, Olga. Yes, everybody, this is amazing, the series of webinars that Olga has put together to assist you guys in building, making the best beer for the competition. And you will see after the webinar, there is a survey. Please make sure that you answer the survey, because in that way, it will just give Olga more information in terms of understanding in what other ways she can support and assist you. Jacques, once again, thank you so much for your time. Thank you for a very informative presentation. And we're looking forward to seeing all of you back on Thursday. I think Maraldi's topic is so important in assisting in terms of the do's and don'ts on the labeling. And we're looking forward in hosting you on Thursday again. Thank you very much and have a pleasant afternoon. Thanks, Olga. Thanks, Jacques.
Cheers, everyone. Thanks.